Okay, this is the magic floating carbon sheet. And I'll tell you why carbon is so important in a minute. You put that on there in the right orientation, it floats. And it's quite stable, floating there, stationary. There's another one that also floats. And those two things float for the same reason that that magnet floated between these two carbon sheets. Now, I will tell you, that these two carbon sheets are what makes the whole thing work. And I can illustrate that better over here. Here's a big piece of that carbon stuff. And if I find a place on the table where it doesn't want to roll. When I bring up the magnet, it pushes it. If I start with it stationary and let go, it pushes it away. If I turn the magnet 90 degrees, it just sits there. If I turn the magnet back, it pushes. What the heck is going on? All right. This magic carbon stuff is diamagnetic. Diamagnetic means that it is magnetized, but in the opposite direction to the applied magnetic field. Here's a graph of the magnetization vertical and the magnetic field here on the horizontal axis. This is CVD carbon magnetic moment versus the applied field. Now, when the magnetic field is perpendicular to the surface of the carbon, it's the red curve. So you get a lot of negative magnetic moment when you apply a positive field. When you apply the field in the plane, like we did here, the effect is much, much smaller. The point is that this stuff repels magnets. When the magnetic field of the magnet is perpendicular to the plane, it repels. And that's why this neat little demonstration here works. This magnet and the little magnet are all magnetized in the same direction, and so this big magnet is supporting the weight of the little magnet. And it returns just like a child's swing. When the child is out like this, that magnet pulls it back. However, it would be unstable in the vertical direction. What would happen if it's a little too high, it would zip up. And if it was too low, it would fall down. But because I've got these carbon sheets in here, two little blocks of carbon, it doesn't. It's stabilized. Now what's happening here is that I've got four magnets here that are very, very strong, that are holding each other together like crazy. They have very strong magnetic fields above them and very high magnetic field gradients. In other words, the field is changing very quickly with distance. As a result, it exerts a force on that carbon sheet that's enough to support the weight. Okay, a little addition to this device here. This is stable because I have the diamagnetic carbon above and below the magnet. Well, our bodies are also diamagnetic, mostly made of water. Water is diamagnetic. Some people in Paris worked out a situation where they could actually suspend the magnet between their fingers. And that must be like magic indeed for the owners of the fingers.